Hi everybody, this is Tor Storley and I am back with another video. In this video, which is part 3 of a series I do for using a F# library for Excel financial functions that I'm using in VS Code. So I will look at some more of those financial functions in this video. And hopefully you get to see a little more of how to call them, and hopefully it will give you some value. So without any further ado, I want to keep this video a little shorter than normal. So let's get started. So what I decided to do to demonstrate some of the other functions besides the depreciation that we went through in part 2, I created a couple of spreadsheets, but let me show you you've seen this already if you watched my previous video. There's this spreadsheet called Excel FIN Functions XLSX, and all these will be on my GitHub repository for this video series. And I went through this last video. So as you can see here, this will be one of the workbooks that we went through. And the other one I prepared for this particular video is this one here. It's called Excel FIN Functions 2 XLSX. So this is the one we're going to be using. And the way I laid this out, just so you have a reference point, is that I introduced some of the financial functions. I selected a few. I didn't include everything. So as you can see here, at the bottom, I named the tabs according to what the function is. And I made it really simple. So let me show you what I mean. For this function here, it uses what's called a present value function. And you can see the actual input values here. So when you click on this function here, and you put it like an F2 format, if you click on the PV in the function name, over here on the sidebar, as you can see, you get information about the present value function. And if you scroll down, you can see the input values and how they're calculated. So if you have monthly, you have to take the annual percentage divided on 12. And if so, you have to take the number of years and multiply by 12 to get the correct input. But this will give you information about how to put values into these functions. And of course, if you're a finance major in college or something like that, you should already know this kind of material. So if you look here, you can see they also list some related functions here. But on the bottom, as you can see, sometimes they give you the formula that Excel is using. But if you look at the bottom here, you can see this is the input values, and down here is the function that with those input values that will actually create this. And down here, as you can see, is the formula that is being used. So in this case, you can see the present value is A3, which is 8%, divided on 12, paid out on an insurance annuity at the end of every month. So they tell you how they expect this input to look like. And then you have 12 months times A4, which is the years. So whenever you divide this on 12, you have to multiply the years by 12. Okay, so that gives you those two inputs. And then here, notice they skip the future value. You can leave it blank, or you can put in 0. That's perfectly fine. Now, this last piece here is something called a type. And that means if you put a 0 in, it's calculated as of the end of the period. If you put a 1 in, that's calculated as the beginning of the period. So sometimes when you have interest payments, depending on whether you start paying right away or if you can pay at the end of the month, that's what that means. You have to specify the default is 0, meaning the end of the period. So be aware of that because that will change your calculations. Now, if you want more detail about these type of formulas, make sure you check out my time value of money video that I created. That will have a lot more detail on many of these functions. So make sure you check that out. That will give you additional information about this because I'm not going to spend an awful lot of time on each function here. So the bottom line is that each function will have a descriptor like this. It will have the interest rates and years and so forth. Then you'll have that formula. And that will give you basically how to compute this stuff. So what I did was I used all help information, if you will, on the sidebar here for each one of these functions. I took this spreadsheet And this is what I want to do. And I want to replicate it in my code. So if I open my Visual Studio Code and I go to my programs, let me bring that over here. The way that works is that I have this program file that has all the code. And if you look at my previous video or my first video, you'll see I went through this. So if something has to do with depreciation, today what I want to do is I want to point out a couple of things only. I have some helper functions, but these relate to the maker's percentage that I did in the previous video. But here I got some parameters, and if you look at these parameters here, you can see that I have a getter and setter, because this is a C# code, for each one of them. But some of them, what I do is I use IEnumerable because I want to pass in arrays of values. So for some of these functions, it expects arrays of dates, or they expect arrays of values, basically for input. So if you look here, I got for the net present value calculations, and I have for the X net present value calculations, and I also pass in for those, I pass in the dates. So as you can see, I added a little more than the previous code that I showed in the previous videos. So I added some more stuff. Another thing I changed was this part. I allow you to pass in how many decimals you want the answers to be in. So whether you want to see 2 or 3 or 4 decimals, you simply specify that by using this term, but I'll show you that in a second. So the default is 2 decimals, but if you want 3 or 4, you simply pass that along and it will use that for that particular one. Here I'm simply setting some parse arguments because it's a console app and I want to pass in values to the console main function. So here what I'm doing is I'm just setting some default values, and this is where I'm going to be parsing all the stuff that comes into that main function. So if you look down in the main function here, you can see it looks like this. So it expects this args array as strings, as you can see. So that's what it's expect to come in. And then what it's going to do, it's going to pass in all these arguments to this parse argument function that you see above here, this big function here with all these weird values. And I'm going to loop it, as you can see. And then I'm using a switch argument for each of those arguments. I'm going to check and see, is it this one? Is it this one? Or if so, do this, etc. So that one will parse out all the arguments I'm going to need into this P class. As you can see here, P is specified for this up here. So that's what I'm creating with that. And then I'm loading that in here. And then when I'm done with that, I have some functions here that will work for formatting the output. So I format if it's currency, I format if it's percentage, and notice whatever you're passing me in or the default will go here. And then I have one for plain vanilla numbers, like number periods or whatever. So that's how my layout is. And then I have this switch statement that looks for, in this case, whatever I loaded now into that instance of the class called P. So if it's the Excel function, I'm checking to see what function is it, if it's a present value, future value, what have you. And if so, I create a variable that's going to hold the output of my call to the financial functions present value, and then I'm passing in from that class these parameters. Now, you can play along with this and you can study this a little more. I don't want to spend much more time on it, but as you can see, I have one case statement for each type of function. Now, these are singular functions, but you also get to this kind of scenario where you have multiple inputs, I should say. So as you can see here, I'm passing in for the net present value the periodic interest rate. But as you remember from above, I have these IEnumerates here. So those are the NPV values. So that's an IEnumerable, as you can see above here too in the tooltip. And then when I get the result back, I simply format that into this format currency, in this case, and whatever number of decimals, either the default or the one you're passing in. And then finally, I'm just writing out the result so you can see what it looks like. So that's kind of how this works. And you can look at this yourself, and you can look at the code for the previous video if you want to look at the depreciation stuff that I did there. The only thing I changed in this one is I added formatting to the depreciation output too. So if you want to download the code, make sure this is the one you're going to be looking at. So, okay, now that you've seen how this works, there is two versions of how you can do this. If you want to run it in a terminal, you can do that by doing this. And in order for me to make this work, I had to do something like this. I have to say .NET run, and then these are the parameters, those args that I'm talking about, that I'm passing in. So as you can see here, I'm passing in -- Excel function. So this is the Excel function. So what happens is if I'm looking for this particular one, which is the XIRR function right here. So this is the case statement. Now, you can run it here to compile it or what have you, but if you want to run it fast, I want to use the compiled version. So how do I do that? Well, one way I can do that is to go to wherever this project is. To simplify my work here, I simply added a bat file, this one, that looks something like this. So my code here sits in this folder. So in other words, the executable will be in the bin folder on the debug under, in this case, .NET 8. So I'm simply doing an echo off so I don't get all the messages back. I'm CDing or change directory, and then I use this so I don't have to do additional things to get to it. And then I simply call up a command executable. So this one works for me to get very quickly to that place. So when I double click here now, you can see now I'm inside the directory where the Visual Studio Code sits, and then I'm inside the debug.NET 8. So what I prepared is a list over functions. It's called Excel Financial _ testing.txt. And when you look at the time value of money, this call here to this executable, I'm passing in for the present value, and I'm passing in the parameter for periodic interest rates. And because it has to be a monthly thing, I'm dividing it. So if you go back to my spreadsheet for that one and look at it, you can see 8% divided on 12, because you need it, the monthly will be this amount. So that's the 8 over 12. So if you look at that, it's 0.6666, but when you actually list it as a real percent, it would be 0.08, like this. And if you divide that by 12, like this, you can say this one is kind of formatted as percent already, but this is the number you need, 0.00666. If you keep going here like this, you can see it's more and more sixes. So this is the number in that file that you see in here. That's the one I'm using for present value, because I want to match the example given in Excel. So by using this, you should match each one of those help file examples in Excel, so you can actually compare how you can do it using Visual Code, doing the same thing as you did in Excel here. So number of periods will be 240. Why? Because 20 years times 12 is 240. So you can see it over here. I'm doing all those inputs in this file here, and I'm going to make that available to you. And then you can see you have payment value of 500 in this case. So let's see where that comes from. Payment of 500, which is this one here, the monthly payments. Okay, so once you have that, the future value is 0. In here, you can see I added a 0 here for future value. And then you have the end of year, end of period, because it's 0 here. The type is, it could be a true or false as well, but 0 will be end of the period. So that's 59,777,15, something like that. Okay, so let's see how this works then. So what I'm going to do, I'm going to copy this guy like this. I'm going to go into my command window that I opened up that sits in this folder. I'm going to paste it like this. And when I hit enter now, you can see it comes back. Present value is 59,777.15. If you look at the output from Excel over here, you can see It's the same number, 59777.15. And I use 2 decimals. Now, what if I want more decimals? Well, all I have to do is add one more parameter, and it's dash dash. All of them are dash dash. It's called num decimals, like this. Then I say if I want 5 decimals, maybe, then I do this. And as you see now I'm getting 5 decimals. So it's pretty cool because it will let you set how many decimals you want. So that's one function. And I'm not going to repeat myself. I'm just showing a couple of these functions because I want to keep it short. And you can try this out yourself. And you can see I have a couple of payment functions because if you look at the payment tab here, in the Excel examples, they had 2 of them, as you can see. And here you say, this was as at the beginning of the period. So what does that mean? Well, the only difference, of course, is going to be this 1 now because it's at the beginning of the period under the type here. End of the period will be 0, and it's a default, so you don't even list it here, as you can see. You could list it. In other words, you could say 0 for future value, 0 for the type. When you do, you should get the same stuff. So either way, I want to point out that I don't like because I think it's wrong. So if you look at this is the NPER function, the number of periods, in other words. There's 3 examples, as you can see here. There's this one here, and the second one and the third one. So if you look at the descriptors here, it says periods for the investment with above terms, except for the payments are made at the beginning of the period. This one is at the beginning of the period too, so that it doesn't appear to be right to me. And it should say end of period. I think there's a mistake here because this is really using the end, because look, the type here is not beginning because it's left out. If it was beginning, you have a 1. If it's an end, it's 0, but because that's the default, you don't need it. So it's really the end of the period. So this one should say end of period. So that I don't think is the right descriptor at all. Now this one here is confusing too, because it says periods for the investment with the above terms except for a future value of 0. Okay, so if you look at it, the future value is 0 now. We set that here, and we set it to a 1, which is going to be the same as the input values. When you do, you're getting 9.4881. But look over here. This is the result they expect, 9.578. So that's not correct either, because that's basically using the end of period, as you can see here. There's no input of 1 here. I used an input of 1, which is kind of what they're saying. They given the answer as it was the end of the period. So I think they should have added the end of the period like this. So I think the last 2 here are poorly written, and they should be changed because that doesn't appear to be correct to me. Anyways, I want to point that out. The rest of these formulas you can look at yourself. What do you do when you have this kind of stuff? If I want to find out XNPV, but basically what that is, that you can have certain cash flows at different points in time. First one was made on 1/1/2008. The second one was 3/1/2008, and so on. But notice the way I pass it in here. I pass it in like it's string because I parse it out. So even though I use the IEnumerable, as I'd mentioned before, it would be parsed out, the string, by using the split function and using the comma. So if you look at my code for the parsing, you can see here that when I scroll up to the parsing function, you can see here, for example, that I'm splitting the XNPV values by comma, as you can see. So this will make it into a IEnumerable list, and that's what that one is doing. Notice I'm passing in 2 arrays as strings. The XNPV values, which is the input, the initial investment, plus all the cash flows, and then the dates that happened, which doesn't have to be in specific sequence. It could be all over the place, as you can see here. It's not every 2 months or every month or something like that. Of course, I could add, if I wanted to, the num decimals, and let's say I want 3 this time, and then hit enter. And let's see, it computes this one output value, which is 208664 something. So if I look at that for Excel, for that input, which is this one. There it is, 208665. So anyways, this is how you can use these functions in Visual Studio Code, and you can compare it to Excel. And I have all the stuff that I've been using so far in here, and you can try it out for yourself and play around with it. So I hope this was informative. I hope you liked this video, and if you do, please give me a like. It really helps. Thank you so much.